Good afternoon, everybody. I hope you are having an amazing day. Yesterday, if you'll remember, we set up our unit circles. We talked about going between degrees and radians. And so today it was going to be a little bit of an introduction to some vocabulary, just some of the general stuff that you're going to need to know as we're going through angles. Some of the references, some of the phrases you'll need to remember. So it's going to be a relatively lighter lesson as far as material goes. So let's just jump straight into it. A couple of things here. You've got coterminal, reference, and special angles is the topic for today. So again, these are going to be three terms, three vocabulary words that we're going to be working on. First is coterminal angles, excuse me, which are two angles in standard position that share a terminal side. Alright. Now, standard position, this guy right here, means that the angle starts at 0, 0. It includes the x-axis, and then it rotates from there, either in a positive or a negative manner. Okay, so standard position means it's going to be at the origin. The main angle that you're measuring is at the origin. So coterminal are two angles that share a terminal side. So the way you can think about this is, let's say you have a 30-degree angle here, right? If I was to go the remainder of the way, let's say 360 degrees this direction, and end up at the same angle, that would be 360 degrees plus the original 30 you started with. That'd be 390 degrees, wouldn't it? Alright? So if you think about this, if you go counterclockwise, you're going to add 360 degrees. Then, of course, you could go the other direction, and you could go from here and subtract 360 degrees and end up on the same terminal side. So if you go clockwise, you're going to subtract 360 degrees. That's very simple. That's what coterminal is. You go with your angle, and you either add or subtract 360 degrees, or if you're in radians, 2 pi. So down here on the bottom, it says to give two angles, one in a clockwise and one in a counterclockwise, that are coterminal to these things that are listed here. Now the first one is 500 degrees. Now think about 500 degrees. You could take the algebra approach to it and just straight out say 500 degrees plus 360 and 500 degrees minus 360. That's the algebraic method, 500 degrees plus 360 and minus 360. So that would give you the plus 360 would be 860 degrees. Minus 360 would be 140. Anybody who's a fan of skating, of the X Games, if you've ever seen anything like the X Games, you know that you're not limited to just one rotation, right? I mean, in real life, you're not limited to just 360 degrees. If you think about what 500 degrees is, a little drawing here, if you start at 0 and you go one full rotation, that's 360 degrees, right? So you go with 360 degrees. The difference between those is 140. So now you go an extra 140 degrees. That angle is 500 degrees. Just like in the X Games, you're not limited to just one rotation. You can do 2 full rotations and get 720 degrees. You can do as many rotations as you want. Alright? So this is the algebraic method again. So negative 60 degrees. Start with negative 60 degrees. Add 360. Negative 60 degrees and subtract 360. Let me turn this down just a hair. So negative 60 plus 360 is 300 degrees. Negative 60 minus 360 is negative 420 degrees. So we're not limited to just one rotation. If you think about the graph of negative 60 here, it's going to be down this direction, right? We learned that if you're in a negative, you're going a clockwise rotation. Alright, let's go over here to pi over 4. Let's start with this one on just drawing pi over, drawing pi over 4. Pi over 4 is in the first quadrant. Now we're in radians here. So I'm going to take my pi over 4 and I'm going to add 2 pi. Add one rotation. Take your pi over 4 and subtract 2 pi. And we know that we can't do that unless we have common denominators here. So this is kind of like saying 8 over 4, right? This is like saying 8 pi over 4 for common denominators. So you've got 1 pi over 4 plus 8 pi over 4 is 9 pi over 4. Same thing down here, common denominators puts this at over 4 and this at 8 pi. Multiply by what you need to make the denominators the same. Pi minus 8 pi is negative 7 pi over 4. I'm going to go a little bit faster on this last one here, just for the sake of time. Negative 2 pi over 3. If we're going negative, here's 0. Here's negative 1/2 of pi. Here's negative 1 pi. So negative 2/3 is going to be somewhere in between. Oops. Negative 2 pi over 3. Okay, and then we set it up the algebraic method. Excuse me. Negative 2 pi over 3 plus 2 pi and negative 2 pi over 3 minus 2 pi. Remember to get your common denominators here. So if it's over 3, this is going to be 6 pi over 3. 6 pi over 3. So negative 2 plus 6 is 4 pi over 3. And negative 2 pi minus 6 is negative 8 pi over 3. So pretty simple concept. All you're doing is adding and subtracting 360 and 2 pi. That is called a coterminal angle because it ends on the same terminal side. Again, coterminal angles are what those are called. Let's go over here and throw a new guy in the mix. Reference angles. This is going to be the one thing you will use probably more than anything, is a reference angle. Coterminal is cute. I mean, it's good to know, but reference angles are useful. We'll show you why a little bit later as we go on. The reference angle, that little a is called alpha, is the smallest positive acute angle determined by the x-axis and the terminal side. The three most important things are underlined already here. It's the smallest positive acute angle determined by the x-axis and the terminal side. What that means is that if I give you some random angle, like, oh, let's say this, the reference angle is the distance between there and the x-axis. So this is the reference angle here. If I give you something over here, this is the reference angle. If I give you something down here, this is the reference angle. If I give you something over here, this is the reference angle. So it always goes from the angle to the x-axis. Alright, I don't care where it's rotating from, to, or whatever. We'll see a little bit of that here in just a second. Draw each angle in standard position, find the reference angle alpha, label theta and alpha. So first, draw an angle that's 150 degrees. Here's 180, here's 90, so it's going to be somewhere up in here. Since we're sketching, it doesn't have to be 100% accurate. 150 degrees. Always draw the rotation there, because there's a difference between 150 degrees, right, and negative 210. Big difference there, even though they are coterminal. Okay, so this is your theta, right? Theta is 150 degrees. That means that this angle right here is alpha. Now notice where it's going to. It's going to 180, right? So you could say that alpha is your 180 degrees minus 150 degrees. In other words, what's the distance between the two? Well, that's 30 degrees. So here, your alpha is 30 degrees. Makes a little bit more sense when you're looking at the graph versus the equation, because when you get into something like number 6, the equation can sometimes be harder to see. So 315 degrees is down here, quadrant 4, so here's your rotation. 315, that's theta. So which x-axis is the closest now? This x-axis right here is the closest. So what I'm going to do in that case is say, if I keep rotating to here, how many degrees will that be total? Full trip. That'll be 360, won't it? So I'm going to say that alpha is 360 degrees, and I'm going back now. I'm going back however many degrees this is. So let's take away the 315 and see what the difference is. That's 45 degrees. Okay? So it's pretty straightforward. 7 says theta is 4 pi over 3. Think about where that's at. 0, 1/2 of pi, pi, 3/2 of pi. So 4/3 is going to be down here. So there's 4/3 pi. You can deposit, pause it. I like radians because they are so easy to figure out the reference angle. They are so easy. All it is pi over your denominator. To get back to here, it's just going to be pi over 3. Let me show you mathematically why that is. If you were to take, let's say we got alpha is 4 pi over 3 minus, where's it going to now? See, if this was 180 degrees, we would subtract this 180 degree piece, and that would give us this little leftover. But this is radians, so we'll call it minus pi. Alright, so common denominators, this is 3 pi over 3, which is pi over 3. So you can look at number 8, see it's pi over 6, and just understand that the reference angle is pi over 6. But let's prove it. Ooh, this is interesting, a first quadrant. Here's your theta, it's pi over 6. So think about that. What's the shortest distance back to the x-axis? Well, it's right here. So alpha is also pi over 6. Alright? So reference angles. Reference angles, reference angles. So determine how to find the reference angle in each quadrant. So if it's in quadrant 1, just like we found up here, if it's in quadrant 1, alpha is going to equal